Dolphin echoes, how they see with sound the ocean depths, are a realm of perpetual twilight, and for dolphins, vision alone isn't enough to thrive there. They've developed an extraordinary sense echolocation that allows them to see their surroundings in a completely unique way. It works like this: dolphins emit clicks and whistles, high-frequency sounds far beyond human hearing. These sound waves travel through the water and bounce back when they encounter objects, fish, rocks, even other dolphins. By analyzing the timing and intensity of these returning echoes, a dolphin creates a detailed sound picture of its environment. It's remarkable they can determine not only where something is, but also its size, shape, and density. Imagine navigating and hunting using just sound. That's the reality for these incredible creatures. Dolphins possess an incredible sensory ability called echolocation, allowing them to see their underwater world with sound. It all begins when a dolphin produces a series of clicks and whistles. These aren't just playful noises, they are carefully crafted acoustic signals that travel through the water like invisible beams. These sounds bounce off objects in their environment, from schools of fish to the seafloor itself. The returning echoes paint a detailed picture for the dolphin, providing information about an object's size, shape, distance, and even its density. It's a truly remarkable adaptation that allows them to navigate and hunt effectively, especially in murky or dark waters where visibility is limited. Dolphins rely heavily on sound to understand their world, and a key part of that is echolocation. They emit clicks and whistles, sounds far beyond our hearing range, that act like underwater spotlights. These sound waves aren't just sent out, they bounce off objects in the dolphin's environment, whether it's a school of fish, a rocky seabed, or even another animal. Those echoes then return to the dolphin, not through their ears directly, but primarily through specialized fatty tissues in their lower jaw and head. The dolphin's brain analyzes these returning signals, interpreting differences in timing, intensity, and frequency to create a sound picture of what's around them. Dolphins don't just send out clicks and whistles, they actually focus those sounds to create a targeted beam. Deep within their lower jaw lies a specialized organ called the melon. It's made of fatty tissue, almost like a natural lens. This unique structure acts as an acoustic focusing device, shaping the outgoing sound waves into a precise direction. Think of it like how a flashlight concentrates light. The melon does something very similar with sound, allowing dolphins to pinpoint objects and navigate their environment incredibly effectively. Once dolphins emit these clicks and whistles, they listen intently for the returning echoes, a process we call echolocation. What's truly fascinating is how they receive that information. Unlike humans, who primarily use their ears to hear, dolphins have specialized fat-filled canals within their lower jaws. These canals act like incredibly precise antennas, funneling the faint echoes directly to their inner ears. It's a remarkably efficient system, allowing them to pinpoint the size, shape, and even density of objects in their environment with incredible accuracy. This sophisticated adaptation highlights just how uniquely dolphins have evolved to thrive in an underwater world. Dolphins possess an incredible ability called echolocation, and it's far more sophisticated than just making clicks. They actively analyze the time it takes for those sounds to bounce back as echoes. This allows them to pinpoint the distance of objects in their environment with remarkable accuracy. Imagine a dolphin sending out a sound pulse. It's essentially creating its own underwater map. The speed of the echo's return tells the dolphin precisely how far away something is, whether it's a school of fish or a rocky reef. This process is strikingly similar to radar technology we use here on land. Both rely on analyzing reflected signals to determine distance and location. It's an amazing example of natural engineering. The strength of an echo isn't just about distance, it actually tells dolphins a lot about what they're seeing. Think of it like this: a large whale will bounce back a much more powerful signal than a small school of fish. Similarly, a dense object, perhaps a rocky outcrop on the seabed, reflects sound differently than something less compact like seaweed. This variation in echo intensity allows dolphins to not only identify objects, but also get an idea of their size and what they're made of, all without even seeing them directly. It's an incredibly sophisticated way of feeling their environment. The incredible detail dolphins gather from their echolocation isn't just about distance and size, it's also about texture and shape. Think of it like this: the sound waves they send out bounce back with subtle shifts in frequency, a phenomenon called Doppler shift. These changes, incredibly tiny, are analyzed by the dolphin's brain to create an intricate acoustic image. It's how they can tell if something is hard like a rock or soft and yielding like a fish. The difference between a smooth seabed and a coral reef, or even the precise shape of a hidden crab, all revealed through these minute frequency alterations. This sophisticated ability allows them to hunt effectively in murky waters where visibility is poor. Dolphins possess an incredible ability: echolocation. It's far more than just making clicks. It's a sophisticated sensory system that allows them to see with sound. They emit high-frequency clicks and then listen carefully for the echoes bouncing back from objects in their environment. These echoes provide information about the size, shape, distance, and even density of what they encounter. Imagine trying to navigate a dark or murky underwater world. Echolocation is how dolphins create a detailed sound picture of their surroundings, allowing them to hunt effectively even when visibility is near zero. It's truly remarkable how they interpret these complex sonic reflections. Dolphins possess an incredibly refined sensory system, far beyond what we might initially imagine. They don't just rely on sight and sound, they navigate and hunt using echolocation, a biological sonar. This process involves emitting clicks and whistles that bounce off objects in their environment, creating a detailed sound picture. The returning echoes provide information about an object's size, shape, speed, and even its density, allowing them to pinpoint prey hidden in murky waters or locate obstacles in low visibility. Their ability to interpret these subtle variations demonstrates an extraordinary level of adaptation, enabling them to thrive in diverse aquatic habitats, from shallow coastal zones to the vast open ocean.